And how do you make pizza? Is it flour, cheese, and spinach? So we're healthy.
Interesting pizza you
Yes.
talked about. Hello, everyone. Welcome back to another episode of Tyler Time. I am Tyler McNerney, here with Tyler Trott, as usual, and we also have two esteemed guests from the company, both from the dev team. We have Jagganadh, who is the chief architect of the app protocol, and Sitaram, who's also a backend developer on the app protocol. Would you guys want to give a brief introduction of yourselves, starting with Jagganadh?
Sure. So I've been an architect of the protocol, and I'm with that company for more than a year now. We have opportunity to architect and probably write from the first line of code to whatever it is today. We have opportunity to code that, and it's a privilege to be part of associated with that protocol. That's me.
Thanks, Jagganadh.
Sita.
Hi, I'm Sitaram. I joined as QA with the company and moved to as a developer. And currently, I'm working as a backend developer for the server and client. And it's pleasure working for at company.
Thank you both. So for today's episode, Tyler Trott will be going through a demonstration of the @Cookbook application, which you might have seen in the @Demos repo. @Cookbook is an intermediate level application similar to @Chats, although probably a little bit more complicated than @Chats, just because as opposed to using functions from a library, we'll be actually implementing some of the more advanced verbs that are provided by the app protocol, namely the notify verb. So with that, I think I will turn it over to Tyler, who will start with a demo and then walk you guys through the different classes, the different methods and verbs that are used in the project. Back to you.
Thank you, Tyler. And as always, we start at the login screen. From the previous two Tyler times, you have the Hello World login and the @Chats login. It has not changed, believe it or not, just like I promised. So we're going to pick an @sign today. And unfortunately, I don't know which ones we're going to pick. Let's do Samiraja today. And we're going to click login, and that's going to have the same authentication process as usual. And there we go. So we're now taken from the welcome page to, the welcome page to this home page. And this home page has two sections to it, where it has a list of my dishes and also a list of shared dishes. Now, because we haven't made any dishes yet with Samiraja's or have had any dishes shared with us, you won't see anything, but we can change that very quickly here. We're going to add a dish to share. And I said pizza earlier, now I want pizza, so let's make some pizza. And cheesy goodness. And how do you make pizza? Is it flour, cheese, and spinach? So we're healthy.
Interesting pizza you
Yes.
talked about.
Do we need an image? Should we waste?
It's optional. I don't think we need to.
No, because it's optional, let's leave it. Our pizza's too good to have a picture of. And add cuisine, and there it is, our pizza with its cheesy goodness. If I navigate to this page here, you can see all the ingredients, the picture if we were to have added one, the title of the recipe itself, which is pizza. And we have two options, remove or share it. So we will be sharing it. I'm going to have to remember who we share it with. It'll be @Alice for simplicity. And we're going to share the cuisine. And once that shares, I'll pop us back to our recipe. And I'm going to quickly hot restart this so I can log in as @Alice. And you can see that I've actually sent the recipe through here. It's really cool. Okay, and now I sent it to @Alice. So we're going to log in as @Alice. Log in. Gonna let that authenticate. Should see. Oh my, there we go. Perfect. Oh, we have fettuccine on here. Cool. As you can see, there are some recipes that still persist, and there's pizza with its cheesy goodness and all of the ingredients. So I guess with that, we can hop right into the code, right?
Sounds good to me.
Awesome. So here's the code. We'll be walking through the complete version of this as it is a little bit more complex to code through and keep up with. So we start here at the welcome page where you do the login methods. As you can see, it's just a copy paste job of the previous two demo apps. The only difference is, as usual, is what screen you were taken to afterwards. And we can move on to the home screen after you have authenticated properly. So if you scroll all the way to the bottom, you'll see two functions. One is scan and one is lookup. And Sita, would you like to take it away for the scan?
Yeah, sure, Taylor. Thank you. And on the scan part, we will be getting all the keys that are not cached to display on the home screen. So the regex there, it will be there to just omit the cached keys, and the call at getted keys would get the keys from the server.
Sounds good. And just to update our viewers a little bit, because up until now, all of the AtKey objects that they've played with, presumably with the Hello World application, have been just stuff that they've pushed and put into their own secondary. So what exactly are cached AtKeys? If you could explain that a little bit to the viewer who might not know what that is.
Yeah, sure. So keys that are shared by other Atsigns can be stored as a cached keys in our Atsigns. So for example, if here, if Samiraja is sharing a key kind of a pizza to allies, then it will be a cached key on the allies for the pizza recipe. So it will be something the allies will have hold a cached key of pizza that has been shared by Samiraja.
That makes sense. Thank you. In terms of the rest of it, yeah, Jaggan, please.
Just to add, actually, you can't just cache by yourself. It has to have. So the person who originally shared the key should give you permission so that it can be cached. So if it's Bob that's sharing with Alice, so it's phone at Bob that's being shared with Alice, you can in fact share it in two ways. In a non-cached way, where Alice has to always come to Bob's secondary and look it up. Other way is Bob is just fine for Alice to cache it, which means the key is in Alice's secondary, which means the time to retrieve is fast, but it's the Bob who decides whether it can be cached or not. It's not the other way around. So it's obvious, but this other thing is, yeah, that's the main.
That makes sense. Thank you, Jaggan.
Okay. And so what's happening in this for loop here after we make that list of strings for the response list, we are looking up the key of the recipe itself, correct? And that's in our case, what we sent to Alice was pizza. And so we're looking up that AtKey, which is pizza. Is that right, Jagganadh and Sitaram?
Yeah, the only thing is, in the home screen's case, we're only looking for keys that are shared with ourselves.
Exactly. There we go.
So yeah, so like the fettuccine.
Yeah, there
exactly.
We go.
The fettuccine key would be passed in. Correct.
And also, in addition to that, with the title, which would be fettuccine, you see this constant splitter, and I should be able to find it here. And it is that @_@, and that is what is splitting the information of the recipe itself. So the @key key is the pizza. Its description is cheesy goodness, and then it's separated by that constant splitter. So what we're doing here is pretty much building this whole item that you see here with the title of the recipe, and then we're splitting the information, and then we're adding the value, which is the the description and the ingredients itself and the image, if we have an image. And then we add it to that list. And if we had more dishes, they would be listed down. So
Sounds
with
good.
that, yeah, with the lookup function now, we're just getting that @key. Ooh, that's a lot.
It's a mouthful, yeah.
Yes.
But there's definitely more to come.
So I guess we move on to the share screen or the add dish screen first.
Why don't we go to the add dish screen first, because it's a little bit easier. And maybe if you want to show what that screen represents on the emulator.
That is this one. If I click that plus sign, correct?
Yeah, exactly.
Okay.
I'd be happy to explain this update method real quick, because it's identical to the update method that we saw in the Hello World application. The only difference being that rather than a single string for a value, we're passing in multiple strings for the value, because we have a description, we have a list of ingredients, and we have an image URL that could be passed in to flesh out this dish widget. So if we look at the update function that we wrote, assuming that all of the necessary text form fields have been populated, we make a new variable called values, and you can see that we're basically just splicing together the different components of this dish. Underscore description is the string variable that encapsulates the description that's passed into that second text form. Yeah, exactly, the part that Tyler Trott's hovering over. And the constant splitter, as Tyler mentioned previously, is just there so that when we kind of parse through the value retrieved in the home screen.dart file, there is a splitter that the split method can detect, so that it segregates the long string into a list of strings for each of the parameters of this dish widget. And assuming that the image URL is not equal to null, that once again is an optional parameter, we tack that image URL also onto that string of values. And the only other thing we do, we initialize an @key object. This is, once again, the standard object that you use to share key value pairs between secondary servers on the app protocol. And we use the put verb from the service file that we have incorporated into this project to add that @key and those values to the secondary server corresponding to the @sign that's currently logged into this application. And then we just pop out of that page.
Yep. And then from there, we can navigate to the actual dish screen itself and then share it. So let us go to that share now. And there's a single function here, the share. I think it's a very convenient name. And after, just like the @chats, when you pick an @sign to chat with, we go through that whole initialization of making that @key object or the recipe to actually send itself. So we make changes to the attributes of the recipe, where we call the title into the key, which is, let me whip up here, fettuccine or the pizza, for instance. And we also have the shared with @sign. I would bring up the secondary server code, but I think that's a lot. It's really overwhelming really quickly. And what is happening here, Tyler, with this get lookup?
Yeah, I'll explain that, and then I think I'll hand it over to Jagganadh for an explanation of the TTR, and then the big notify verb that we have awaiting, no pun intended, at the bottom of this function. So what we're doing here, you can think of that first @key object as a sort of dummy @key object. What do I mean by that? Well, we want to get the values corresponding to the @key object, the @key object being like pizza. And then with the value that we retrieve from that @key object, which is what we do in that server demo service.get call, we want to make a new @key object with the appropriate attributes, right? You can see that there is an additional attribute called metadata, as well as shared by And the shared with this time is no longer the currently logged in @sign, which is contained in the @sign variable, but it's now this other @sign variable that we're passing into the shared with, which you can imagine is the @sign we want to share this newly made dish object with. So then I'll hand it over to Jaggan for what exactly is this metadata object and how is that being used to make this @key object, which is being notified to another secondary server.
Yeah. Metadata is actually used. It has few other attributes, which probably you can cover later. For example, the popular ones are is encrypted and there are a few other attributes. So when the information that's part of the metadata would also be passed to the server, and server then decides to act differently based on the information that's available in the metadata. In this case, TTR is -1. So TTR stands for time to refresh. So what server does at this point is it tries to inform the other secondary that, you can cache my information by virtue of TTR, but since it's -1, I'm trying to give you a piece of information that I'm almost certain that it's not going to change. Whereas let's say if you put a TTR as a finite value, you want the other guy to actually look it up every now and then. Let's say if the TTR is a day, then the information that I'm sharing typically bound to change in a day, and I want the other @sign to come and look up my secondary so that they can look at the new value. So the metadata has various other attributes. In this case, I think the thing of our interest is TTR. That's how it works. So anything else, Tyler, that you want me to cover?
Yeah, that made a lot of sense. Thank you. I think then we can move to the notify verb that's being used at the end of the function, where we have the @key and the value passed in, but there's also this operation variable that's passed in when we call the notify verb. Would you be able to give, I guess, an overview of what the notify verb is doing, and B, what exactly that operation variable is doing?
Yeah, exactly. So the operation could be like update or delete. In this case, you are setting a value to a key. It could be a new value or update to an existing value against a key. So you want to notify, when you notify to other secondary, you would notify along with the operation. Let's say the importance of the operation is when the operation is update, it's simple. The other guy would keep the key and the value is either a new value or updated value. So the cached value gets updated, and that's how it is. But let's say as somebody who shared the key, you have deleted the key. Then you want to notify that, hey, this particular key that I have shared with you, for example, office phone, my current employee's office phone is something that I have asked you to previously cache, but I have changed my job, so it's no longer valid. Then I would delete that and I notify the same to the other secondary, which the code looks exactly same, just that the dot notify @key comma value in case of delete doesn't have any importance, and the operation would be delete. So when you receive such notification, the other secondary would go about clearing its cache too. So it's basically propagating a delete operation to various other people who would have cached. So a secondary acts differently based on the operation.
That makes sense. Thank you. Any questions from you, Tyler, or are we good to move on?
So I think I wanted to kind of throw in, if we wanted to instead send fettuccine to someone and we wanted to actually delete that fettuccine, all we'd have to do is pass in the fettuccine @key for the recipe and then just change the operation to delete. And that would send the request to delete the fettuccine. And it's as simple as that. Okay, so I think we can move on to the other screen now, correct? Yep. And here we have the two functions. And you'll see again that there's another regex, and Sitaram can go over what the difference between the regex in the home screen is and this regex.
So the regex here, it just gets all the cached keys in the current @sign. So getting back to our earlier example where Samirja has shared a pizza to Alice, here we wanted to see all the shared dishes and the at Alice side. So we just get all the keys that are cached on at Alice. And on the home screen there, we wanted to get to see the keys that are created by us, which are the non-cached keys. So we have a regex where that will return all the keys that are not cached or the non-cached keys.
And then on this other screen, the cached keys are in fact looked up. And of those cached keys, we want the ones with the correct shared by and shared with attribute. Would that be accurate, Sitaram?
Yes, Taylor.
Perfect. And Tyler, do you want to show the other screen once again, just to distinguish between the home screen?
And there it is.
There we go. So then, as Sitaram was saying, this pizza recipe, this pizza dish, is in fact cached in accordance to Alice's secondary server. So this was originally shared, as Tyler did at the very beginning of the demo, by Samiraja, if I'm understanding correctly. Okay, that makes a lot of sense. Anything else we wanted to cover here, Tyler?
Did we want to quickly go over what's happening in the pub spec for this one?
Sure.
So we're using the @client mobile and @server status, including the @demo data. So the @demo data being all of the testable @signs, their encryption keys. I don't think we're actually using @server status, are we, Tyler?
I think it's really only used in the service file. I don't think we explicitly use any of those methods in the classes that we have here. But yeah, the list of dependencies that we have for the @cookbook is identical to what we had for @hello world. So you can see that with the same dependencies from the beginner project, you could accomplish still a lot more just by understanding that, yes, there are a lot more verbs that you can play with that belong to the protocol.
Okay, I think that is it. Were there any final remarks from you, Jagganadh or Sitaram?
Thanks for featuring us.
You're very welcome. Thank you for making all of this.
Very true. With that, yeah, I think we can wrap things up. So it was a pretty short episode, but we hope we provided some insight into the more intermediate and advanced verbs that exist in that protocol. So hope you incorporate this into your own @protocol and @platform projects. Thanks, everyone.
Thank you.
Take care.
Thanks.